Some more problems from section 1.2, and this is number 7. And we have y equals 2 plus the square root of x minus 1. Now this is a situation where we do have some natural restrictions on the domain x because we can't have a negative under the radical. So if x is 1, this is okay because we can have 0 under the radical because the square root of 0 is 0. But if x was less than 1, like negative, well, even if x is 0, we would have negative, the square root of negative 1. We can't have that. So x has got to be greater than or equal to 1. Okay? So my domain would be 1. That's the smallest x can be. And then it can be anything bigger than 1, because if it's 2, we're okay, or 3. So we would say 1 to infinity is the domain. Okay? Because again, if x is smaller than 1, we're going to have a negative under the radical. Now the range would be the result of putting these domain values in here. And like we said, the smallest this can be is going to be 0. Because if x is 1, we have 1 minus 1 is 0. So the square root of 0 is 0. And 2 plus 0 is 2. So that's the smallest this can be, and then we're just going to be adding positives to that, so it's going to get bigger and bigger than 2 as we add numbers that are bigger than 1. Like if x was 5, 5 minus 1 is 4, square root of 4 is 2, 2 plus 2 is 4, so it's going to get bigger. So the smallest value I could have would be 2, so my range would be 2 to infinity. Okay? Now if we graph that, if we look at this, this is going to be our square root function. So the way I set this up was the square root of x minus 1 plus 2. And again, what we did in the summer assignment, I think 4 and 5, or 4 or 5, this is in there, is basically we have got the square root function, but it's going to be shifted. And if we subtract 1, we're going to shift it 1 to the right and up 2. Now what does that parent function look like? Well, that's the square root function. So this is over here. And sometimes we call that John Travolta from, Saturday Night Fever, this little disco movie he did with his hand. Okay, so this is our parent function, the square root. But what we're going to do is we're going to shift that 1 to the right and up 2. Oops, sorry. Okay. So if I look at that, we know that what's the square root of 0 is 0, so that's normally where it's at. Then the square root of 1 is 1, and the square root of 4 is 2. So 1 is 4, the square root of 4 is 2. So normally it looks, and I guess I should maybe pencil that in for you. This is the normal parent function like this. Square root of 1 is 1, and the square root of 4 is 2. Okay? So that's the normal parent function, okay? But when we look at our function, we're going to shift this. So basically, you can just shift this point over, and I'm going to go 1 to the right and up 2. And then the square root of 1 is 1, and the square root of 1, 2, 3, 4 is 2. So I kind of extended that a little bit, so I could use this graph paper. And that's what your graph would look like. Okay? Parent function, and then with the horizontal shift of 1 to the right and a vertical shift of positive 2. Okay? And number 9. Well, we have a fraction here. We know we can't have 0 in the denominator. We'll have a vertical asymptote. It's undefined when we have 0 in the denominator. So x can't be 2. It could be anything else as long as it's not 2. So the way we write that is we go negative infinity to 2, open. The infinities are always open, to 2, union, and then we're going to go, this is open, so we can't be 2, and then we're going to go 2 to infinity. That's how we get that domain. Okay? Now the range, we're not going to have 0, so we don't have to worry. Now we're going to have 2, so we don't have to worry about 2 being in there. So the range can be pretty much any value as long as x is not 2. The only thing is that in order for a fraction, whenever you have a fraction with a constant in the numerator, it can't be 0. All right? How can a fraction be equal to 0? The only way a fraction can be equal to 0 is if you have 0 over something. You can't have 0 over 0. It's not in the domain. In other words, when that x would be 2, 2 minus 2 is 0. So we don't have that in the domain. So we don't have to worry about 0 over 0. So we're going to have 0 over some constant. And then the fraction will be equal to 0. Well, this can't be 0 because it's a constant 1. So this can never be equal to 0. So our range would be all the numbers except for 0. So we do the same little trick over here. Negative infinity to 0. And then 0 to infinity. And that kind of omits 0. Or you could always say all numbers except for 0. Or you could say all numbers except for 2. That's just another way of writing it. Okay? Now this is our 1 over x parent function. And that's upside down, excuse me. And that's this one here. And sometimes we call that swoosh. It just goes swoosh like that. And you can see how x can't be 0 and y can't be 0, but we have a shift on this other function. So let's see what we're doing. So when I graphed it, it's just shifted over. And it's the same idea. It's x minus 2, so it's just shifted 2 to the right. That's all. We can just think of parentheses. So instead of being 1 over x, it's 1 over x minus 2. Kind of an understood parentheses there. So I just shifted my axis, which would be my vertical asymptote when x is 2. I just shifted it over 2. And then you can draw it in the same way. And we usually have a 0.11. Okay. In this case, when x is 3, what's 3 minus 2? 1, so we have 1 over 1. And then we usually have one like this around the axis, and then you can kind of sketch your curve in. So it's just shifted over. And we do have a horizontal asymptote at 0. So that doesn't change, but you could put some other points in if you want, but otherwise this sketch would suffice. And it's just, again, it's just our swoosh parent function just shifted over. I want to make sure that it's approaching those asymptotes. We do, in this case, we do have a horizontal asymptote of 0, but a vertical asymptote of 2. Okay. So I hope that makes sense. And again, we did a lot of these in the summer assignments, 4 and 5.